Welcome to another enlightening episode of Lengua Viva Cultural Insights, hosted by the ever-curious John Parker and the insightful Amanda Mitchell. Today's episode promises to be a captivating journey through the intricate history of our understanding of language neuroscience. Join John and Amanda as they unravel these monumental milestones in the field of language neuroscience. Remember to support Lengua Viva Cultural Insights by joining their Patreon community, where you can access exclusive comprehension exercises, vocabulary lists, infographics related to each topic, and transcripts to enhance your listening comprehension.
Ready for a deep dive into how our brains process language? Buckle up, because we're about to decode the secrets behind your sources today.
And it's going to be a fascinating journey. But you know what's interesting? To understand how the brain handles language today, we actually have to take a trip back in time to a not-so-scientific practice.
Phrenology.
Phrenology. Oh, you mean the feel your skull for personality traits thing?
Yeah.
Yeah, I remember learning about that and thinking, wait, they were serious with that.
It sounds pretty wild now, right? But phrenology, even though it was completely debunked, it did kind of pave the way for the idea that different parts of the brain might have specific jobs, almost like, a specialized team.
Okay, so maybe not the most accurate career aptitude test, but hey, sometimes you got to start with a crazy idea before you get to the brilliant ones. Exactly. And speaking of brilliant, when it comes to language, there are two areas of the brain that quickly rose to fame, Broca's area and Wernicke's area. These two are like the star players on your brain's language team.
Okay, I'm intrigued. So tell me, what happens when one of these star players is benched?
Well, picture this. You understand everything you read and hear, but when you try to speak, it's like your words are stuck in a traffic jam. You can't get them out in any kind of order that makes sense. That's the very real and very frustrating reality for people dealing with Broca's aphasia.
Wow, that sounds incredibly isolating. One of the sources even talked about a man who could only say one word, tan. It's heartbreaking.
It is, and it really underscores just how important Broca's area is for putting words together in a way that's fluent and grammatically correct. It's not just about knowing the words, it's about the mechanics of speech.
So, if Broca's area is like the team captain calling the plays, what about Wernicke's area? Is that more like the coach coming up with the game plan?
That's a good way to think about it. Wernicke's area is all about understanding the meaning of words and sentences. So if Broca's is the captain on the field, Wernicke's is like the playbook, making sure all the plays make sense. If Wernicke's area is damaged, it leads to something called receptive aphasia.
So with receptive aphasia, someone might be able to speak fluently, but the words are just salad, like a bunch of ingredients tossed together, but not really a cohesive dish.
You got it. Imagine trying to have a conversation with someone speaking a language you've never heard before. That's kind of what it's like for someone with receptive aphasia. Their sentences might be grammatically correct, but the words they're using just don't make sense in that context.
Wow, okay. So we've got our captain, Broca's area, making sure we speak clearly, and our playbook, Wernicke's area, ensuring we understand what we're hearing and reading. But something tells me there's more to this story.
You're right, there's always a twist. It's not as simple as just two areas working independently. Our brains are way more interconnected than that. And there's actually another type of aphasia that really throws a wrench into things, conduction aphasia.
Conduction aphasia. Okay, what makes this one stand out from the lineup?
Well, with conduction aphasia, you can understand language just fine, and you can speak fluently, but here's the curveball. Repeating what someone just said. That's the challenge.
Wait, really? If you can understand what's being said and speak yourself, why would repeating be a problem?
It seems counterintuitive, right? But this little quirk actually reveals a lot about how different areas of the brain are wired together when it comes to language.
Okay, now I'm even more curious. Tell me more about how this conduction aphasia sheds light on our brain's language network.
It's like finding a secret passage between two bustling cities. Imagine Broca's area and Wernicke's area as these cities, each with their own language industries. Conduction aphasia is like discovering a crucial trade route between them that for some reason is blocked. The cities are functioning, but that essential exchange, that's where the breakdown happens.
Fascinating. So it's not just about these two key areas, but also the communication lines between them. It's less like a simple game of catch and more like coordinating a whole orchestra.
A symphony of brain activity, for sure. And speaking of complex systems, one of the sources you provided actually delves into an early attempt to map out this entire orchestra. It's a model that, while not entirely accurate, had a huge influence on how we understand language in the brain.
I'm ready to hear more about this model. What were they thinking back then, and what made scientists realize it needed a revamp?
So this is the Wernicke model. Pretty straightforward name, right? Basically, it tried to explain the entire journey of language processing in the brain. Picture this. Information comes in through your ears as sound. Then it's like a relay race. That sound gets passed to Wernicke's area, which figures out what it all means. Then the baton gets handed off to Broca's area to plan out how to respond. And finally, the message sprints down to your motor cortex, which is in charge of actually making your mouth move to speak.
I'm visualizing this relay team sprinting through my brain right now. It's a vivid image, but I have a feeling it wasn't quite that simple in reality.
You're right. The brain is rarely ever that straightforward. The Wernicke model made it seem like these areas worked in a strict sequence, one after the other. But really, it's way more dynamic than that, more like a lively debate than a linear race.
So instead of a relay race, it's more like a group chat, with multiple people weighing in simultaneously.
Exactly. We know now that language processing involves many more brain areas, all working together in a more intricate dance than initially thought.
Okay, so they needed a whole new dance routine to capture what was really happening. What were some of the aha moments that led to this realization?
Well, one of the biggest game changers was the development of brain imaging technology. Suddenly, instead of relying solely on observing people with brain injuries, researchers could actually peek inside the brains of healthy individuals while they were using language.
Wow, it's like they went from studying static maps to observing live traffic patterns. That must have been huge.
It was a revolution. And what they found was mind-blowing. They discovered that different tasks, even seemingly similar ones, activated different networks within the brain. For instance, simply reading a word versus hearing a word spoken aloud, those lit up different areas.
So it wasn't just one straight highway, but a whole interconnected network of roads and pathways, each with its own purpose. What a fascinating shift in understanding.
It really was. And that realization paved the way for a much more nuanced and sophisticated model of language processing, the dual stream model. This model suggests that there isn't just one pathway, but two parallel streams of processing happening at the same time.
Two streams. Okay, so it's like having a backup generator in case one fails. Tell me more about these streams and how they operate.
Not exactly a backup system, but more like a dynamic duo, each with its own specialty. One stream, called the ventral stream, focuses on understanding what we hear, like a detective analyzing clues. This stream flows from the auditory cortex, where sounds are first processed, to areas in the temporal lobe. Think of the temporal lobe as the brain's massive library of words, grammar, and meaning.
So while I'm listening to you, my ventral stream is hard at work, decoding your words and trying to make sense of them. What's the other stream up to in the meantime?
Okay, so the second stream is called the dorsal stream, and this one's all about action. It's like taking that decoded message and figuring out how to respond.
So kind of like that moment right before you hit send on a text, you're making sure everything is spelled right and that you're conveying your message clearly.
Exactly. The dorsal stream connects the auditory cortex to the areas of the brain that plan and control the movements we need for speech. It's like the brain's construction crew taking the blueprints from the ventral stream and building a response.
So while I'm listening to you right now, my ventral stream is busy understanding your words, and my dorsal stream is prepping my vocal cords for a reply.
It's happening right now without you even realizing it. It's a pretty amazing example of how our brains multitask.
It's mind-blowing when you really think about it. We've been talking this whole time about Broca's area, Wernicke's area, this model, that model. But what's the takeaway here? Why should we care about all these intricate details?
It's easy to take language for granted, right? But think about it. Language is at the core of what makes us human. It allows us to share ideas, tell stories, build connections with each other. Understanding how our brains make all that happen,
Well,
it's like peeking behind the curtain of our own humanity.
it's like we've been speaking the secret code our whole lives, and now we're finally starting to crack it. It's fascinating to unravel the mysteries behind something we do so effortlessly every single day.
I know, right? And think about how you use language every single day to connect with the people you love, to learn new things, to navigate your world. It's not just about the words themselves. It's about this incredible orchestra of brain activity happening behind the scenes.
It's making my brain feel like it's doing the tango just thinking about it. But it's true, when you pause and really think about it, it's incredible how much is going on beneath the surface that we just take for granted.
And the amazing thing is, we've only scratched the surface. We've been focusing mainly on spoken language, but there's a whole other world when it comes to reading and writing.
That's right. We haven't even touched on how our brains process the written word, which involves a whole other set of pathways and brain areas. That's definitely a deep dive for another time. But for now, we've given our listeners a lot to think about. So to everyone listening, pay attention to your own language use. Notice the nuances, the complexities, the way your brain effortlessly switches between understanding and speaking. You're experiencing the magic of neuroscience every single day. Until next time, keep those brains buzzing.
Words that flow like rivers do. Learn a language, join the crew. Every lesson something new. Lengua Viva here for you.
Grammar rules and vocab tight. Practice every day and night. Conversations feeling right. Change your world with words so bright.
Lengua Viva, take a chance.